Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 8, looking at Lessons 16 and 17, modeling with systems of inequalities. So in our last lesson, we talked about these systems of inequalities. Today we're going to look at some real-world problem examples where we could actually use a system of inequalities to help us um, deal with the information we have. So let's jump into these examples, and I'm going to use Desmos as well to show graphs of these. But so this first one, it says it takes 30 ink cartridges and 180 pages to print a book, and it takes 25 ink cartridges and 80 pages to print a magazine. Sarah wants to print books and magazines without exceeding 250 ink cartridges and 1,000 pages. So we've got those are her maximums that she wants to use. We're going to let B represent the number of books she prints, and M is going to represent the number of magazines she prints. We want to set up a system of inequalities to represent this situation based on the number of ink cartridges and number of pages. It's not asking us to solve this one. All right, so we want to think of this in terms of ink cartridges and then pages. So if we think of the ink cartridges, so it's 30 for each book. So 30 times the number of books, and then 25 times the number of cartridges, and we're using M for, or excuse me, yeah. So 30 times the number of books, 25 times the number of magazines. That cannot be greater than 250, so it has to be less than or equal to 250. So that would be one of our inequalities. And then we're going to do the same thing looking at pages. So it's 180 pages for each book. It is 80 pages for each magazine. That needs to be less than or equal to 1,000. And so those would be our two inequalities for this one. It didn't ask us to solve it. I'm going to go ahead and show you the graphs for these. In Desmos, I have to use X and Y. So X is the books, Y is the magazines. And so if we were going to solve this, anything that is inside of the double shaded area would be a possible solution. This one right here, if we did 2 books and 7 magazines, we would need to, that would be a constraint because we wouldn't want to do a partial book or partial magazine. Also, another constraint that we talked about would be we couldn't have negative books or negative magazines as well. All right, so let's jump back in then to our second example here. And this one says Lacey's selling lemonade and popsicles to raise money for a trip to the local water park. A cup of lemonade costs 75 cents. An ice pop or popsicle costs $1. She needs to raise at least $28 total. So she knows she's going to sell more than 20 items. We're going to set up a system of inequalities, and we're going to determine if selling 20 cups of lemonade and 15 ice pops meets our constraints. All right, and so let's think in terms of money here. We're going to make X is going to be our lemonade. Y is going to be the popsicles. All right, and so it's 75 cents she makes, or she's earning for each lemonade. It is $1 for each popsicle, and she needs to raise at least $28. So she wants that to be equal to or greater than $28. Our second inequality is going to be our items, our number of items. So if we take the number of cups of lemonade, the number of popsicles, she is saying she knows that's going to be more than 20. So X plus Y is going to be greater than 20. All right, and here we want to know if she sells 20 cups of lemonade, 15 ice pops, is she going to meet the constraints? So I could plug in 20 for X, 15 for Y, make sure that it makes both of those inequalities true. I'm going to go ahead and use my Desmos calculator to help me find that. So if I pull up my Desmos, I have graphed the two inequalities, and then I also plotted the point for 20 cups of lemonade is X, 20 is X, 15 is Y, the popsicles, and you can see that point here. It is in our double shaded area, so that means it does fit our constraints. It would, that is more than 20 items, and she would earn more than $28. All right, last one then. It says, Haley is buying chicken wings and hamburger meat for a party. One bag of chicken wings costs $6.50. Hamburger meat costs $3.50 per pound. She must spend no more than $35, and she also knows that she needs to buy at least 5 pounds of hamburger meat. So we want to write a system of inequalities, and then we're going to solve. So we are going to have X represent our hamburger meat. Y is going to, oops, sorry, I've got that backwards. They gave us chicken wings first. Let's make chicken wings our X value. Sorry about that. So X is our wings, Y is our hamburger. And so if we think in terms of money, $6.50 times the number of bags of chicken wings, we have $3.50 times the number of pounds of hamburger meat. She must spend no more than $35. So it needs to be less than or equal to 35. Our second inequality here, the only other constraint we have is that she needs to buy at least 5 pounds of hamburger meat. So that means that Y has to be greater than or equal to 5. So those are our two inequalities. To solve, I'm gonna go ahead and use my Desmos calculator one more time here. So I have my two inequalities. The red shaded area is for our first one here. And then the hamburger meat more than 5 pounds, that's the blue shaded area. So anything in the purple is a possible solution. So here we can't buy, and thinking about constraints, we have to buy a whole number in our bags of chicken wings. So so we could buy 2 bags of chicken wings, and then if we're able to buy in portions of a pound, that point right there, we could buy 2 bags of chicken wings and a little over 6 pounds of hamburger meat, and that would be our best situation there that we could do. But really anything in that purple area would fit our constraints and be a possible solution. All right, and that's all I've got for you guys today. Appreciate you taking the time to watch. If you do have questions, please let us know. Thanks. Have a great day.